Hi, it is Friday, April 6th, and I'm Miss Matzi coming at you from Geosystems. So let's take a look at what we did in class today. Today is Friday, April 6th, 2018. It is a B day. Today in class, our objective was I can model a watershed in order to create a definition of the components of a watershed. Those components are things like rivers and tributaries. We did the crumpled paper watershed, we took some notes on rivers, and then we worked on the stages of a river packet. For homework tonight, you have the SOL prep packet, the first week for the SOL review, and then if you didn't finish this in class, the stages of a river packet, and turn that in, then you have that with you to complete for homework and bring back next class on Tuesday. A river cuts through a rock, not because of its power, but because of its persistence. That's us right now. That's us as a class. So I know it was hard for students to get here on Friday, and a lot of us were very, very tired, but just like how this river has cut down and cut through this rock over years and years and years and years through persistence, that's what we're doing as well. We're showing up, we're attending school every day, we're completing our work, we're passing it in, and believe me when I tell you, your hard work is going to pay off. Let's look at some of the main points that we learned today. One of the main things we talked about was a watershed, and a watershed is basically like a basin or a bowl that's divided by this ridge line right here, this yellow line. And so that yellow line was the ridge line that you drew on your crumpled piece of paper with the marker. So it's the top of the mountain, and any rain going on the inside of it is going to go into that watershed. Watersheds contain things like rivers and tributaries. Tributaries are little rivers that are flowing into the larger river. Now, we also talked about the stages of river development and how rivers can go from the very top of the mountain where they're very young all the way down to the ocean where they're very old. So let's take a look at the top of the mountain. The top of the mountain is a V-shaped young stream that's main process is down cutting. So it's just cutting down into the rock, but it's for the most part a straight river or stream. Now a mature stream is much flatter, the gradient is much flatter, and the river starts to meander or bend back and forth. And then finally the old stream down here at the bottom closest to the ocean is very flat, very curved, very meandered. Sometimes you'll see oxbow lakes, and then you see a delta as the river enters the ocean because the velocity completely drops when the river enters the ocean, and so it drops all of its sediment. Now, here's another thing that we need to talk a little bit more about. On the top of this diagram, you see a river, and you see that on the outside of the curve, like right here, this is where the river is moving the fastest, so this is where you're going to have the most erosion. But on the inside of the curve, the water is not moving as fast, so sediments are being deposited on this side. Then when you come over here to the top of this curve, you have the erosion happening on the outside of the curve, and on the inside you have deposition. Then the river flows over here. Now on the outside of the curve here, you're going to have erosion. This is where the river is flowing the fastest, but on the inside the river is flowing a little bit slower, so you're going to have deposition. Here on the bottom, you'll see a cross-section of that. So you see that the river is flowing really fast on the outside of the curve, so it's wearing away this rock slowly but surely with a persistence over time. But on this side, the river is flowing a little bit slower, so it starts to drop some of the sediments and it deposits them on the river bottom. Here's another example of that, and you can see here on the outside of the curve the river is flowing faster, so it's eroding and you have this wall right here, but on the inside of the curve it's depositing sediments. Now what this causes over time is what's called an oxbow lake. So if you start over here, you see you have erosion on the outside of the curve, and then erosion on the outside of this curve here, and then erosion on the outside of this curve here. Over time, these curves are going to get closer and closer and closer to each other until one day during a flood, the river takes the shortest course through these necks right here. It just jumps right over during a flood, and it's going to cut off this really large exaggerated curve, but that curve is going to become what we call an oxbow lake. So that's no longer part of the river system anymore, but it will just stay there filled with water for a while. So don't forget that if you haven't already done so, you want to finish the stages of a stream activity that we did in class. And then you also want to do your JLab, your SOL assignment, your SOL review assignment. You want to make sure you get that in because, like I talked about in class today, there is no late work accepted on that SOL assignment. So it is due on April 12th. I hope you have a great weekend. You really did great work today, especially with your attendance. Like, people are really coming to class. You're really doing great work. I'm so happy to see that. Attendance is 80% of your success. We're almost there. Your SOL is on May 21st and May 22nd. Everybody's doing a great job. Everybody's learning. I see it. So have a great weekend. Rest up, and I will see you on Monday or Thursday.